Hello, Math 1 students. Mrs. Robinson here to work a couple problems from section 5-2 with you that weren't on your video. Remember, you can always go to pearsonrealize.com to get those problems that don't show up on the videos. But this one, problem 4 on their video was our problem 3, and problem 4 and 5 weren't on there. So let's go ahead and go over them. The online problem, this is what's in your workbook for the Got It. But the online problem, remember, those are at Pearson Realize. And I'm going to pull this over. Here's the online example for problem 4, and let's work this together. Remember, you can click on it. There's a solution here where I can click on this, and if I click on the solution, it will pull up how to work this problem for you. Let's work it. It says this: a culture of bacteria is growing in a petri dish. The mass of the bacteria, initially 1 gram, doubles every hour. The mass of the petri dish is 50 grams, just the petri dish. So the total mass in grams of the bacteria and the petri dish after x, so many hours, is given by this function, 2 to the x plus 50. What's the graph of the function, and what do the terms 2 to the x and 50 in the function represent in this situation? Well, what do they represent is the easiest question to ask right off the bat. They told us already what they represent. They said the mass of the petri dish is 50 grams. So what does the 50 represent? It represents the mass of the petri dish. Okay. I'm zooming in, sorry. And then, what does the 2 to the x represent? They already told us the mass of the bacteria is initially 1 gram and it doubles every hour. So 2 to the x is the total mass in grams of the bacteria after x hours. So this is the mass in grams of the bacteria. If it doubles every hour, you would start out with 1 gram, and after 0 hours you would have 1 gram. After 1 hour you would have 2 grams because it doubles. So you'd start out with 1 gram, then after an hour you would have 2 grams. If it doubles, I should have 4 grams. So this would be 0 hours, I would have 1 gram. At 1 hour, because it doubles, I should have 2 grams. At 2 hours, it doubles. I should have, from here to here, doubles. I get 4 grams. So at 3 hours, I should have 8 grams. And this is the perfect function to represent that, because 2 to the 0, at 0, I would get 1. If I plug in 1 for x, 2 to the 1st, I get 2. If I plug in 2 for x, 2 squared, I get 4. If I plug in 3 hours for x, 2 cubed, I get 8, and so on. So how I'm going to graph this is simply like this. I'm going to hand draw this. It's not going to be very pretty. I'm not going to go into the negative because I'm not going to have negative hours. And I'm just going to go ahead like this. 1, 2, 3, 4, 5, 6, 7. And because I can see this is going to go up high, if I plug in 4, 2 to the 4th, is actually going to be 16. And if I plug in 5, 2 to the 5th is 32. So this is a table of f of x equals 2 to the x, not the plus 50. We're just going to graph the base function here first. So I'm going to go ahead and calculate this by maybe, let's go 5, 10, 15, 20, 25, 30, 35. Let's go by 5s just because my numbers go up really quickly. Just to hand graph this, 20, 25, 30, 35. Okay, so if I were to graph f of x equals 2 to the x, I'm going to go over 0 up 1. So right about here, okay, I'm going to go over 1 up 2, not to 5 yet, over 2 up 4, not even to 5 yet, over 3 up 8, so almost to 10, over 4 up 16, a little bit above 15, then over 5 all the way up here to 32. So I can see the shape of my graph is exponential. It curves up like this, okay? And it has a constant increase of multiples of 2. I'm multiplying by 2, multiplying by 2 all the way through. Now if I'd like to add 50 to that, all I'm going to do, if this is my x values and this is my f of x values, I'm going to come over here and do my x values and my f of x values, except for this time my f of x is going to add 50 to it. So I would like to do this function. F of x is 2x plus 2 to the x, sorry, not 2x, 2 to the x plus 50. So I'm going to get the same output values here, except for I'm going to add 50. So if I plug in 0 here, I get 1. Anything to the 0 power is 1. 1 plus 50 is 51. So when I plug in 0, I get out 51. When I plug in 1, 2 to the first is 2. 2 plus 50 is 52. So you can see I'm going to get all of these same values, 1, 2. If I plug in 2, 2 to the fourth value is, sorry, plug in 2, 2 squared is 4. I don't know why I said to the fourth value. 2 squared is 4. 4 plus 50 is 54. Okay, so I can plug in 3, 4, 5, and I'm going to get these same values here, except for I'm going to add 50. So instead of 1, I get 51. Instead of 2, I get 52. Instead of 4, I get 54. Instead of 8, I'm going to get 58. Instead of 16, I'm going to get 66. Instead of 32, I'm going to get, what's 50 plus 32? 50, 60, 70, 82. All right. So I'm basically going to take all of my same x values, I shifted up 50. So instead of here at 0, 1, I'm going to be at 0, way up here, 50. Instead of at 1, 2, I'm going to be at 152, way up here. Instead of at 3, 8, I'm going to be at 3, 58, way up here. So my y values just shift up. When you add 50, you just shift your y values up 50 and your graph's way up here. Okay? And then remember, the 2 to the x represents the mass of the bacteria that doubles every hour. And then the 50 represents the weight of the Petri dish. So this is just the bacteria. This is the Petri dish plus the bacteria. And if you look at the solution, let's go ahead and solution it. If you look at the solution and not my ugly drawing, so there's the initial 2 to the x, and then here is the 2 to the x plus 50. So instead of being at here, you're all the way up here. Another thing you could do is go to Desmos and graph that and see what that looks like, so it looks a little nicer. Here's what that looks like. Okay, if you just go to Desmos.com, type in y equals 2 to the x power, and there's your red graph. Now see what happens when you go y equals 2 to the x power, and then you go ahead and add 50 onto that. And you can see that graph pulled up, but it's way up higher. So I got to zoom out a bit so I can find it all the way up there at 50. So now it's up here at 50. It's the same graph, it's just way up here. And that's a vertical shift. Now it was minus 50, you would shift down 50. So in your got it, it's another one where you would do the similar thing, but your function this time looks like this: 2 times 2 to the x plus 50. So you could go ahead and graph 2 times 2 to the x and then see what the shift up 50 looks like, or just go ahead and make your chart for this exact function, x and f of x. So you just plug in some values. Start with 0 because you don't want to have negative mass. So start with 0, no, you have no mass. 2 to the 0 is 1. 1 times 2 is 2. Then 2 plus 50. So your first value would be 0.52. Plug in 1. Oh, I lost my table again. 2 to the first power. I'm going to go ahead and write my table back real quick. 2 to the first power would be 2. And then 2 times 2 is 4, plus 50 would be 54. So you should have our first two values, which I lost. I would have 0, 52. And then I plugged in 1, 2, and I got out 54. Plug in 2. 2 squared is 4. 4 times 2 is 8, so I would have 58. Now, if you're going to graph this by hand, you're probably going to want to redo this. Sorry, the graphing tool is giving me a hard time. It's zooming in and out. Let me just go ahead and draw this. It would be, you would draw it along this axis. So we had, and you could label this. This could be 1, 2, and so on. And I would label these by tens. 10, 20, 30, 40, 50, because my values were big. Remember, I plugged in 0 and I got out 52. I plugged in 1, I got out 54. I plugged in 2, I got out 58. Then it's going to start growing really fast. So I'm going to go 0 all the way up here to 52. 1's going to give me 54. 2 is going to give me 58, and then it's going to start growing up like this. Now, if you want to double check it, go to Desmos and graph that. So if I go to Desmos, I'm going to type in y equals 2 times the value 2 to the x power, and then from there, I'm going to go ahead and, I probably need a parentheses here too, I'm going to go ahead and add 50 to that. So it's going to shift my graph way, way up. And you can see when I zoom out that it's all the way up there at 50. And that's what that graph would look like. Okay, to do the online problem number 5, this is what you're going to do. What is the solution? Instead of doing the online, let's do these got it's. What is the solution or solutions to each equation? And look at this little hint. What two functions can you graph to find the solution? Well, what you want is you want to know where 0.3 to the x equals 5. So what I can do is I can graph y equals 0.3 to the x, y equals to 5, and then see where those two lines intersect. And that would give me the solution. So go ahead, instead of doing it by hand, graph them on a grapher like Desmos, or if you have a graphing calculator, go ahead and do that. So you're going to graph y equals 0.3 to the x, and then you're going to graph y equals to 5. And you're going to see where these two intersect. Do that for each one. Graph y equals 1.25 to the x, and then graph y equals negative 2x, and see where these two intersect. Do it for this. Graph y equals to negative 2 to the x power, and then graph y equals to 3/4 x minus 4. And see where those two intersect. Let's pull a couple up on Desmos real quick. I'm going to pull that back over, and let's go ahead and graph that. Okay, so if we graph, let me plug them in real quick. So here I got y equals to 0.3 to the x for part A on the got it number 5, and then I'm going to type in y equals to 5. So there are my two graphs, and where they intersect right there will be the solution. So if you zoom in on the blue and the green, right here where they intersect at the point negative 1.33, 5. So what is my solution? Where is the x value where those two intersect? It looks like it's about negative 1.3. You can round that up to negative 1.34 if you'd like. All right, let's try the next one, part B. Okay, so I typed in y equals 1.25 to the x, the left part of the equation, and then the right part is y equals to negative 2x. What x value is going to make these two true? So let's look and see where they intersect right here at negative 0.45 or 0.452, but you can round it to 2 decimal places. And then let's go to part C. Okay, for part C, I typed in the left-hand side. It was y equals negative 2 to the x. Be careful, that negative is on the outside. It's not raised to the x power. So you do that after you plug in your x value and then do the power, and then you would multiply by a negative. And also the second part is 3/4 times x minus 4. So careful with your parentheses. But if I zoom in, where are the x values that makes that true? Were those two equal to each other? And it looks to me like where the purple and the red cross is that this point 1.517, or you can round to 2 decimal places, round to 1.52. And that's how you do the online and the got it's number 5. All right, guys, I hope this helped. Have a good day.